jamming EcoBlue engine. Ford Ranger 2 EcoBlue XLT Super Cab Engine Code BC2X, 1996 cc. 4-sill, 2019 diesel. The situation described concerns a diesel engine of an off-road vehicle with a 2-liter EcoBlue engine with engine code BC2. That, after a previous seizure and the installation of a completely new engine with new injectors, again shows serious problems such as irregular running. Ticking and knocking sounds as if the engine is running on 3 cylinders and ultimately almost seizes again, despite an apparently correct oil level, and the absence of error codes in the engine management after the error messages have been cleared with diagnostic equipment from 2 well-known brands. With these types of complaints, and especially after a previous crash, a structured diagnosis and repair plan is necessary, in which the engine is no longer tried to start to prevent further damage, and the car is safely positioned in the workshop, after which a step-by-step investigation is carried out to determine what went wrong internally. The first step is always a mechanical check without direct disassembly, for example by trying to turn the crankshaft by hand with a suitable wrench on the crankshaft pulley to feel whether the engine is really stuck or whether there is only heavy compression or a blocking auxiliary unit such as alternator or air conditioning pump. After which the drive belt of the auxiliary units can be removed to check whether the engine then runs easier because a seizing alternator or air conditioning pump can sometimes give the impression that the engine itself stuck. If the engine runs heavily or not at all, even without a drive belt, this strongly indicates an internal mechanical problem such as seized bearings, blocked pistons, or serious damage in the distribution area. The diagnosis plan then includes a compression test, or preferably, a leak test per cylinder for an engine that still wants to run somewhat. But in this case, where the engine may already be almost stuck, it is wiser not to force it any further and immediately disassemble the oil pan to visually inspect the lower engine side and the crankshaft bearings and connecting rod bearings for traces of corrosion, discoloration, or metal particles. This requires the use of standard garage tools such as a bridge, a jack, a set of sockets, torque wrenches, engine mount if the auxiliary beam needs to be removed, and an oil pan. The engine oil must also be carefully drained and filtered or collected in a clean container so that a magnet and visual inspection can be used to look for metal chips or bronze and steel particles that indicate bearing and axle wear. In the case described, it is mentioned that during the first seizure, something with an axial bearing or axial play behind the crankshaft gear was probably defective, which may have caused the crankshaft to shift axially and cause internal damage. This is a serious mechanical problem that can occur again and again if the cause is, for example, a production error, incorrect fit, incorrectly mounted bearing shells, or an error in the oil supply. If the inspection after the second near seize reveals that crank bearings, axial bearings, or connecting rod bearings are damaged again despite a new engine, it is essential to investigate together with the overhaul company whether there is something in the drivetrain outside the engine that causes additional axial load, such as a fault in the clutch or torque converter, or incorrect installation of the flywheel or dual-mass flywheel that pulls the crankshaft forward or backward. In addition, during the diagnosis phase with the oscilloscope, remarkable control patterns of the injectors were seen, namely that injector cylinders 1 and 4 appear to be controlled at the same time, and cylinders 2 and 3 at the same time, which may indicate that the engine management system is not correctly controlling the individual cylinders, or that reference signals from the crankshaft sensor and camshaft sensor are not being interpreted correctly by the engine computer, possibly due to an error in the mounting of the gear ring, incorrect position of the gears, or an electrical problem in the wiring or control of the injectors. With a new engine, it is crucial that the crankshaft sprocket and the reference marks correspond exactly to the software and engine type of the engine computer. If, for example, the wrong variant is installed or the sprocket is not properly aligned or incorrectly mounted, the engine computer can control injection, but at the wrong times, which can cause detonation or knocking noises and heavy mechanical loads that quickly lead to major engine damage again. Therefore, in addition to the mechanical inspection, the diagnosis plan must include a thorough check of all reference systems, including the crankshaft sensor, camshaft sensor, and the associated sprockets and reference marks, whereby the exact time relationship between crankshaft signal, camshaft signal, and injector control is compared with the factory value using an oscilloscope and brand-specific documentation. The diagnostic equipment used, such as the aforementioned testers, is suitable for reading error codes and live data. But for this in-depth analysis, a good oscilloscope is indispensable, as well as access to technical diagrams and reference images of the correct control patterns. This also includes checking the engine computer itself for the correct software version and calibration for the installed engine type variant, because a mismatch between engine hardware and software can cause subtle but destructive deviations. The story also states that there was initially a malfunction in the area of injector cylinder 2, and that in the previous engine a leak in that injector cylinder was also stored in the memory. This can mean two things: either an accidentally failing injector or an underlying problem with the combustion in that cylinder, for example due to loss of compression, incorrect timing, or a mechanical defect in that cylinder, causing the injectors to repeatedly require different corrections and generate error codes. The fact that after replacing injectors 2 and 3, the fault does not return, but the engine still runs poorly indicates that the injector itself is probably not the main culprit, and that the cause is more likely to be mechanical, compression, or timing. Known problems with these EcoBlue engines, as reported on the internet, include problems with the oil lubrication system, including oil dilution by diesel in the oil during many short journeys, problems with balance shaft modules or oil pump drives in some variants, bearing damage, and in some cases issues surrounding injectors and particulate filter regeneration. There have also been reports of distribution problems during certain production periods and of high-pressure fuel pump problems. The production years of this 2-liter EcoBlue engine family for off-road vehicles and vans range roughly from the beginning of 2016 and continuing until after 2025 in various power variants for both commercial vehicles and passenger cars. In terms of maintenance, these engines have strict requirements for oil quality and oil change intervals, and it is wise to change the oil earlier than the maximum factory interval, especially during heavy use such as towing trailers or heavy city traffic. A minor maintenance service on this car usually includes changing the engine oil and replacing the oil filter plus checking fluids, tires, brakes, and lighting, and will usually cost somewhere between 300 and 600 euros, depending on the garage type of oil parts and hourly wages, where the hourly wage in a brand dealer is often higher than in a universal workshop. In addition to this work, a major service includes replacement of the air filter, fuel filter, cabin filter, and periodic brake fluid, and possibly inspection of distribution and auxiliary drives, with costs that can easily range from approximately 600 to over 1,000 euros, depending on additional work such as brakes and suspension. Parts such as starter motor, alternator, and shock absorbers have a lifespan that strongly depends on conditions of use, but on average, a starter motor often lasts between approximately 100,000 and 300,000 kilometers, while an alternator often functions for many years and kilometers under normal use before bearings or voltage regulator cause problems. Shock absorbers generally last between 80,000 and 150,000 kilometers, after which damping noticeably decreases, which is reflected in bouncing, reduced road holding, and uneven tire wear. Preventive replacement of the timing belt or timing chain and associated components such as tension rollers and water pump is very important because a break often leads to serious engine damage, and for this engine the manufacturer's prescribed intervals must be strictly followed. Expressed in euros without figures, this means that a distribution service with belt water pump and rollers, depending on the workshop and parts used, can quickly amount to between 700 and 1,500 euros in total costs, including labor and materials, and that major repairs such as engine replacement or complete overhaul often cost many thousands of euros in parts and labor. whereby a new complete engine including assembly can sometimes cost €10,000 or more depending on the origin and type of engine, and a reconditioned engine is usually slightly cheaper, but still represents a significant investment. To prevent future problems with this engine type, it is important not only to perform regular maintenance, but also to pay attention to driving style and use. Many short journeys with a cold engine cause accelerated contamination of the oil and particulate filter, and increase the risk of oil dilution and bearing damage, while regularly longer journeys at operating temperature help with complete combustion and regeneration of the particulate filter. Warnings from the engine management must also be strictly observed, and fault lights must not be ignored, as this allows emerging problems such as low oil pressure or injection problems to be detected and addressed at an early stage. When purchasing a used car with this engine, an extensive purchase inspection is recommended, in which, in addition to the external inspection and test drive, a complete diagnosis is also carried out with professional equipment in which error codes from the engine and transmission are read, and the correct functioning of the particulate filter, EGR system, turbo fuel system, and measurements of injection corrections are checked. It is wise to choose a car with demonstrable full maintenance as prescribed, preferably with regular oil changes and timely changing of filters and distribution, and machines with an unclear history or many complaints about engine and injection on the internet are better avoided. With regard to the choice between petrol and diesel, the maintenance costs and the risk of expensive repairs due to the particulate filter turbo and high-pressure injection system are often higher with modern diesel engines than with simple petrol engines, especially for drivers who travel few kilometers per year and make many short journeys, so petrol is often more sensible for that use. While diesel can still be attractive for those who drive a lot of kilometers per year with a lot of highway and heavy use. Converted into miles and dollar prices, maintenance and repair costs are broadly comparable, but depending on local labor wages and parts prices in the relevant region, where in some countries diesel parts may be more expensive or cheaper depending on the market and taxes. Back to the case described, it is important for the further process that the workshop enters into close consultation with the overhaul company or supplier of the new engine to determine whether there may be a production error or assembly error, or an incompatibility between engine and engine computer, and that, if necessary, technical support is requested in consultation with the importer or manufacturer. A joint analysis by the engine supplier and the mechanic based on a detailed damage investigation of the seized engine can prevent the same error from occurring again after replacement. With a repair and control plan to improve future maintenance, it can be agreed that in addition to the regular maintenance intervals, additional checks are scheduled, such as periodic oil analyses to see whether there are metal particles in the oil or whether diesel contamination occurs. And for example, a preventive check every year with a diagnostic tester and live monitoring during a test drive to detect early deviations in injection corrections and turbo pressure. You can also decide to have the oil change interval during heavy use compared to the maximum factory specification in order to keep the lubrication system optimally clean. Regarding hourly wages, it can be said that a brand dealer often charges a higher hourly wage than a universal garage company, where, for example, brand dealers can charge close to €100 per hour or more, while universal garages are often slightly lower depending on the region, where in some areas the hourly wage is closer to €60 or €70 per hour, but this varies greatly by country and environment. These hourly wage differences have a major impact on the final costs of major repairs, such as engine replacement or overhaul, which is why some owners prefer to go to a specialized overhaul company or independent specialist for expensive jobs. Various experiences can be found on the internet about this car and this engine, with both positive reports about traction and driving comfort and negative reports about engine damage, turbocharger problems and injection problems, especially at higher mileages or insufficient maintenance. Anyone who wants to buy a reliable car with as little risk as possible of serious engine problems would be wise to prefer cars with demonstrable dealer or specialist maintenance, preferably with lower to medium mileage and without a history of stalling or extensive engine damage, and to stay away from cars with unknown history, many short journeys, commercial vehicle use without a logbook or many complaints in user forums. In summary, the diagnosis and repair plan for this seized EcoBlue engine consists of stopping further starting attempts, mechanically checking the engine for seizures, dismantling the oil pan and inspecting bearings and crankshaft, analyzing oil for metal flakes, thoroughly checking the crankshaft sensor, camshaft sensor, gears and engine computer for correct software and timing, checking the flywheel and drive coupling for excessive axial load, and carrying out a damage analysis in consultation with the engine supplier to determine and remedy the root cause, so that the engine can function reliably for a long time after repair or replacement. By combining this with strict maintenance discipline, timely oil changes, good fuel quality monitoring, and careful handling of fault reports, the chance of recurrence of such serious problems in the future can be significantly reduced.